Hi guys, I wanted to go over a few problems from the 10.5 assignment covering angle relationships in circles. Okay, so for this very first problem, find the value of x. So here's x. We need to find this angle. However, we don't have the intercepted arcs for that angle, J, K, and ML. So we can't really worry about finding x right now. As far as finding this angle. What we're going to have to do is start with our given arcs, 2x minus 30 and 30. And those are the intercepted arcs for these angles. So we're going to find those angles first. So because the angles are inside, if you refer back to your graphic organizer, inside the circle was half the sum. So we are going to take half the sum of 30 plus 2x minus 30, and that will give us an expression that we can put here. Okay, so within the parentheses, 30 and a minus 30, that should cancel to 0. So really we're just taking half of 2x. So half of 2x is just x. So the expression that represents that angle is just x. Well, this angle was represented as x. If you notice, we have a linear pair. So x and x are supplementary. So we can set up this equation. X plus x equals 180. 2x is 180. Divide by 2 on both sides. So x is 90 degrees. Okay, another problem I wanted to work is this one here. Find the value of x. Our angle is outside the circle. So when the angles are outside the circle, it's half the difference between the two intercepted arcs. So my very first arc is 17x. It's the major arc from F to H. And I don't have a representation for minor arc FH in orange. It's not labeled. So I need to come up with a way to represent FH in terms of 17x. So if you notice, the purple and the orange create a full circle, 360 degrees. So I can subtract the part I know from 360. So I can write 360 minus 17x to represent the minor arc. Okay, so I've been given the answer. I've been given the angle. So I'm going to take half the difference of these two arcs and set it equal to my angle. So 75 is half the difference between the two arcs. So 17x is the larger arc. I need to take the big one minus the small one if I want my angle to be positive. Now I need to subtract both 360 and a negative 17x. So a lot of you are doing this in your head. That's great. I'm just going to show what I'm doing over here. I'm taking 17x and I am subtracting the entire expression, which means the negative distributes. I have to subtract both. So I'm subtracting 360 and I'm subtracting a negative, which is a positive. So now I'm going to bring this expression down. So 17x I already wrote, minus 360 plus 17x. Okay, so I'm going to work within the parentheses. 17 plus 17 is 34x. Bring down your minus 360. Now you can distribute the 1/2, or you can just multiply by 2. So I'm going to multiply by 2 on both sides. Half of 2 cancels to 1. 2 times 75 is 150. And then we don't need the parentheses anymore because this is all that's left. Okay, I need to add 360 to both sides, and then I'm going to take care of the 34x. So add 360, and add 360 over here, it cancels. And then we're going to divide both sides by whatever stuck to x, so we'll divide by 34. And we get x equals 15. There's one more I'd like to do. This guy. He has a lot more going on. So You may start somewhere and hit a roadblock, and that's okay because there's a lot going on. You just want to start somewhere and find everything you can. Eventually, we want to find arc AB and an arc ED. So let's start just somewhere, find something you notice, and see if you can find something else. So I noticed that angle A is on the circle. When it's on the circle, the angle is half of the intercepted arc if it's on. So my intercepted arc for angle A, if you drag your fingers out, it goes all the way to D. So in purple here is my intercepted arc. I know that arc AD is 120 since angle A was 60. You just multiply by 2. Okay, so there's something. I noticed that this right here, E to F, is 20. Now the whole thing's 100. I don't know this little piece though, or this piece, so I'm kind of stuck there. So let's start and find something else. The next thing I notice, we have 115 degrees here. So vertical angles are always congruent. I can mark this. And then vertical angles here are congruent. 115 and 65, they're supplementary because they are a linear pair. They sit on a line. So let's see what arcs intercept the 115. We have ED and AC. Okay, we don't have ED and we don't have AC, so we can't start there. So we need to start somewhere else. So let's try the 90 degrees. I noticed the 90 degrees is inside. And so let me find the intercepted arcs. AB and JD. So in pink there, now we know JD if we have ED, and we don't. So we really can't start there. So we need to find something else to do. So we've almost reached the point where we've tried everything, but we haven't yet. If you notice, DC is 85 degrees, and that's the intercepted arc for 65. And then the intercepted arc for this 65 is AE. So we can find arc AE. So let's do that. When they intersect inside the circle, it's half the sum. So the angle is half the sum of my two intercepted arcs. So my first arc is 85, and my other intercepted arc is AE. Now you could call this X. I'm going to call it AE just so we don't get confused of what we're trying to find because there's a lot going on. Okay, so I'm going to multiply by 2 on both sides. That will get rid of the 1/2. And bring the rest down. And then I'm going to subtract the 85. And so I get that arc AE is 45. Okay, well I know that JE is 20, so that makes AJ 25. So that's getting me somewhere. And remember, we found that the purple arc AD was 120. So if I just take arc AD, the purple arc, and subtract what I just found, the 45 degree arc, that will leave me with DE. So let's go ahead and do that. The 120 minus the 45 gives us 75. So I know that arc ED or DE is 75. Now that's something they wanted us to find, so that's good. So we'll bring it over here and box it up.